Right, engineers. So I'm going to assume that you managed to import that no problems and that was all okay. Just send me a message if you have any issues. But once you've done that, you should have a screen that looks something like this. So that's the part that we've been given. You can see you can kind of, if you use the middle button, like you kind of scroll wheel and click it down, you can rotate it, which is useful for selecting those kind of like niggly little areas that otherwise are quite hard to select. The first thing that we need to do is actually change the material that this is made out of. So if you go to the geometry menu there, you click down to 150mm crank with holes, that will select that whole piece. And you see here on material assignment, it's got structural steel. If you just click that little arrow, again, my kind of little left click menus aren't working, but there will be an option for aluminium alloy, assuming you imported it in the way that I showed you in the previous video. So you can click that little thing there, you can see the materials changed to aluminium alloy, that's all okay. So right, that's the first thing done, that's the right material. You also need to put in the remote force. In the assignment, you'll know that the force, the concentration of force is actually 50 mil away from that very back edge of this surface here. So if you want to just select the inside, let's see if I can zoom in. Right, yeah, there we go. You can kind of just about see that, if I can wiggle it around a bit. There we go. That bit's come up in green, that's selected. We're just going to right-click that and go Insert, Remote Point. And again, you can't see my left-click menus, but provided that you clicked on Model A4 in the kind of left-hand side up here, that option will be available to you. And you've got the details of Remote Point down here in the bottom left-hand side of the screen. All of that looks good. Except the Z coordinate, we said it's going to be 50 mil from the back, so I just need to type in 50. It's worth just going up to the units menu at the top here, making sure it's in metric. I've put it in mil just because all the instructions are in millimeters, so you can go up to the units menu up top there if you need to change anything. And as you can see, the remote point is kind of chilling out 50 mil from the base plate, so that's ideal. And then we want to change up the mesh. This is where you can kind of show a bit of creativity, a bit of ingenuity. If I update the mesh here with the just initial settings, you can see that that's it's not very good. There's lots of very sort of large points there where it's not very accurate. So we can go to the mesh menu and you can go to sizing. It's again down in the bottom left hand side. You need to click the plus button to open that up. And you can see that the relevance center is going to be set to coarse, which gives you those large elements there. So you just want to click down to medium on that drop down menu, and that will kind of change your mesh up a little bit. You can kind of update that now. There we go. It's looking a little better, but as you can see, there's still some kind of quite large elements there on this face and the back face here. So once you're in the mesh menu, again, the really important thing with ANSYS is to make sure you've clicked on the right, the right part of your project on this little drop-down menu, so you can get the correct right-click options. So we're just going to select this face here and give it a right-click. Again, I know you can't see my drop-down menu, but you'll have an option to insert sizing. And once you click that, the little sizing box is going to come up here. You can see that the default element size is 5.4 mil. That's pretty big. So I'm just going to change that to 3 mil. That seems like a reasonable size. Again, this is where you use your initiative, show the things you know about ANSYS, and you can change that to whatever you want. And I'm just going to do the same here. Select, insert sizing on the back face. Again, 3 mil. And then if you click the mesh there, you can click update, the little lightning bolt there, and that will show you the new information. Nice thing about ANSYS is when you have made changes, your menus, rather than the green tick, there'll be that little lightning bolt and you know you have some stuff to update. So this is looking much better. So we've got our remote point, which we went through before, we've got our mesh, and then we need to go to the supports. So on this static structural menu, A5, you just got to give that a right click, and there'll be the option to insert, and you want to put either a fixed or frictionless support. I've assumed a fixed support. Basically means that these little grommets here are kind of fixed, can't move. Frictionless support I think would be acceptable. I could be wrong on this, but it's either one of the two. And we just select those little holes. You don't want the inside bit where the screw's going to lie, because that screw's kept tight to the gear, the chainring. And so you just want to click the little riveted areas there where the screw head is going to lie. And then you've got geometry selection. You can just click apply in this bottom left hand corner. So that's your fixed support. And then you want to select this little inside ring. You also want to put a support there. Again, you want to right click, insert. I've put that as a cylindrical support because I believe that's correct, although again this is one of the areas I could be wrong. You can see here you have the three axes of movement along that cylinder: radial, axial and tangential. They're all fixed. You can kind of change the tangential to free if you want some movement in that axis, but I've chose not to. So yeah, you've got that, and now you just need some force. So you want to again click onto the static structural menu here on the left hand side, give it a right click, insert, and you have the option for remote force. That's because we've got this little remote point up here that you can't see at the moment. And rather than you do a geometry selection where we click where that remote force is going to go on the scoping method down here in the bottom left hand side, we just want to click that drop down menu and do remote point. And remote points is now going to come up yellow. You can click that drop down and select the remote point that we made earlier. So you see that kind of all fits in nicely. Down here in this bottom left hand side, this little menu here, you've got a couple of options. You don't want to define it by vector because we've got we need to do three different analyses of this piece. With different force, and it's kind of difficult to get the right direction if you have vector. It can be a bit finicky. So I've chosen to go to components, which is the other option in that drop down menu, and see these three little guys come here highlighted in orange. What's quite nice for the one where it's 90 degrees and the one here where the piece is laying flat, you can just select either a Y or X part of the force rather than calculating the kind of breakdown. And you can use kind of any number here. I'm going to say minus 1,500 newtons. I've kind of looked through a few papers. I think that's about right for a recumbent bike. But you know, you might want to use more or less. That's entirely up to you. I'll probably end up using a slightly different number in my final report. But this is just to kind of show you the ropes, show you how this works. So yeah, I've done that Y component. That's minus 1,500. So you can see it's going down. Doesn't really matter. It's just an aesthetic choice for me. So we have our force, we've got where the piece is fixed, we've got our meshes looking nice, and we've changed the material to aluminium. So this is all good. Then just click on this solution bar on the left hand menu. You see you got that little lightning bolt, so there's still stuff we need to do. And you can select you know, your total deformation here, your equivalent strain, your equivalent stress. There's also some tools up here that you might find useful, you know, especially for sort of your further research. You can do things like the sort of safety factor and stuff, which we may need to do. So I've got the solutions that I want there, and then I can click that little lightning bolt for solve. Now my PC is pretty beastly, but this might take a minute or two. Just okay, yeah, and we're done. So you can see. On the go to the total deformation, the menu here, you can see where the piece is deformed. It looks kind of worrying, but that's exaggerated, so the piece won't actually, you know, deform that much. Don't worry. And you can kind of move that around there with again that middle click button, and you've got the elastic strain, the equivalent stress, and all this data is useful. You can also click on Report Preview, and it will generate your report there. And I think we might need to put that as a what's it called, like a appendix or something, or as an additional file, but it's quite good to know just to see, and you can insert your graphs or anything else as you see fit. Yeah, it's also quite useful. It gives you a breakdown of like the mass, so the weight of the piece and stuff like that. It's actually a pretty powerful tool. So I hope you get on with that well. If you've got any questions, just send me a message, and yeah, best of luck guys, cheers.